Welcome everyone. I am Assistant Professor Milan Patel, ME Electrical Power System from the Mahatma Gandhi Institute of the Technical Education and Research Center, Navsari. Today we will discuss chapter number 1 from the subject elements of electrical design 3160918, and the chapter name is General Design Aspects. So today's flow of contents are difference between electrical and magnetic circuit and insulating materials and its types. Both are important topic regarding GTU examination. The difference between electric circuit and magnetic circuit question previously asked in GTU examination for the 4 marks. So you have to write difference between the electric and magnetic circuit. Insulating materials and its type. This question was asked for 7 marks in previous GTU examination. So let's start with the difference between electric circuit and magnetic circuit. So difference between electric and magnetic circuit. So this is the basic electric circuit consisting of voltage source, DC voltage source. This is the resistance in series with this voltage source. Due to this voltage source, the current I will flow through this circuit. And in magnetic circuit, this is a magnetic core in circular form having a mean length of L. This is the winding having n number of turns, and this is the current applied to this circulating winding. And due to this winding, magnetic flux will be generated and it will flow through this core. This is the cross section area of this particular core, and phi flux will be produced due to this n number of turns and current I, Ni ampere turn applied to this circuit. So in electric circuit, voltage is our input, and in magnetic circuit, Ni means ampere turn is our input. So this is also called EMF, and this is also called MMF. EMF means electromotive force and MMF means magnetomotive force. So now, first of all, definition of the magnetic circuit. The closed path for magnetic flux is called magnetic circuit, and the definition for the electric circuit is that the closed path for the electric current is called electric circuit. Now, relation between flux and current. So flux is equal to mmf by reluctance. Flux is given by mmf by reluctance. So for electric circuit, it is given by current is equal to emf by resistance. So this is mmf by reluctance and this is emf by resistance, means v by r. Now unit for flux. Flux is measured in Weber and it is denoted by WB. Current I is measured in ampere and it is denoted by capital A. Now MMF and EMF. Magnetomotive force is driving force and it is measured in ampere turns. Measured in ampere turns and it is denoted by capital AT. Capital AT. And MMF is given by integration of H dot dl. H dot dl, where H is the magnetic field intensity. Electromotive force is the driving force and measured in the volts. So EMF is given by closed integration E dot dl. E dot dl, where E is the electric field intensity. So if the question will ask for 7 marks, then you have to write 7 points considering with this figure. If it will ask for 4 marks, then you have to write minimum 4 points. For the each circuit. Now next, reluctance and resistance. So in magnetic circuit, reluctance opposes the flow of magnetic flux. And it is denoted by capital S. And it is given by S is equal to L divided by mu 0 A or mu A. L divided by mu A. and it is measured in ampere ton per Weber. It is measured in ampere ton per Weber. So ampere ton per Weber is the unit for the reluctance. Now resistance opposes the flow of current. Resistance will oppose the flow of current, and the unit for the resistance is ohm, and it is given by R is equal to rho L by A. R is equal to rho L by A. Now density. Flux density is denoted by capital B, and it is given by phi divided by A. Phi divided by A. It is given by Weber per meter square. Flux density is measured in Weber per meter square. Same for the current density J. Current density is denoted by J. It is given by I divided by A. I divided by A. And the unit for the current density is ampere per meter square. Now intensity. Magnetic intensity H is given by Ni divided by L. Ni divided by L. And electric density is given by E is equal to V by D. E is equal to V by D. Unit for H is ampere turn per meter. Ampere turn per meter. And unit for electric density is given by volt per meter. Unit volt per meter. Now drops in magnetic circuit is given by MMF drop phi into S. Phi into S. And in electric circuit there is a voltage drop, and it is given by I into R. I into R. So here total 9 points are given. 9 points are given. So you have to first draw this circuit, then you have to give second definition, third relation, then unit, MMF and EMF. So all the points will be write by you in examination for full marks. For full marks. Now next IMP question for the 7 marks. Question is that what is insulating materials, and explain different types of it. Explain different types of it. So first of all, insulating materials are non-metallic materials that does not allow electric current to pass through it at normal temperature. At normal temperature. So the definition of an insulating material is that the materials are non-metallic materials that does not allow electric current to pass. That does not allow the electric current to pass through it at a normal temperatures. At a normal temperatures. Now properties for the insulating materials. Properties for the insulating materials. The first property, high dielectric strength. So insulating material must have high dielectric strength. Second, it has high resistivity. High resistivity. Third one, low dielectric hysteresis. Low dielectric hysteresis. Fourth, good thermal conductivity. Fourth, good thermal conductivity. Fifth one is moisture withstand capacity. Moisture withstand capacity. So insulating material must have a good moisture withstand capacity. Sixth one, chemically inert. Chemically inert. So no, there is no effect of chemical on insulating material. Able to withstand vibration, abrasion and bending. So these 7 properties must have by any insulating material. So now classification based on the substances and materials. Substances and materials. So first one is solid insulating material. First one is solid insulating material. So first its types and examples. So first A, fibrous solid insulating material. So examples for it are wood, paper, carol boards, etc., etc. Now second one, impregnated fibrous. So in this type, impregnated paper, varnished, etc. etc. there. Third one, non-resinous materials. Non-resinous materials. Asphalt, bituminous, corks, etc. etc. Now fourth one, ceramics type solid insulating materials. So porcelain, aluminum, etc. will be in the form of ceramics. Next one is glass. Next one is glass. So in glass solid type insulating materials, silica glass, pyrex, fiberglass are there. And next, natural and synthetic rubbers. Natural and synthetic rubber. So in this type, natural rubber and silicon rubber is there. Natural rubber and the silicon rubber is there. And last one, mica and asbestos. Mica and asbestos are under the solid insulating materials. So these are the different types of solid insulating materials with their example. So total 7 types of solid insulating materials are there: A, B, C, D, E, F, G. Now second one is the liquid insulating materials. Liquid insulating materials. So in this type, first one is oils, mineral oils, vegetable oils, HC, hydrocarbon oils, etc. etc. will be covered in the liquid insulating materials in oil category. Now second one is varnishes. Synthetic varnishes and spirit are in category of the varnishes liquid insulating materials. Now the third and last one is the gaseous insulating materials. Gaseous insulating materials. So in this type, carbon dioxide, CO2, dry air, argon, nitrogen, etc. etc. will be covered. So these 4, carbon dioxide, dry air, argon, nitrogen, are categorized in the form of gaseous insulating materials. So now this is the based on the substances and material. Now classification based on the temperature rise. Now we will do the classification of the insulating materials based on their temperature rise. So we have to make table for it. So first one column for the class, second one is temperature for it, and last one is example based on this particular class. So first of all, Y class. So Y class have 90 degrees Celsius temperature capacity. 90 degrees Celsius temperature capacity. And in this type, cotton, silk, paper, wood will be there. Cotton, silk, paper would be there. Now class A has a temperature range of 105 degrees Celsius. 105 degree Celsius. Cellulose ester or immersed in oil. Cellulose ester or immersed oil is categorized in the class A. Same next, class E for 120 degree Celsius. Synthetic resins, enamels are in class E type insulating material. Now class B type insulating material has a temperature range of 130 degree, and mica, glass, fibers, asbestos are in the category of the class B. Class F has temperature capacity of 155 degrees Celsius. It is mica, glass, fibers and asbestos are also in the category of the F class materials. Now H class materials has a temperature capacity of the 180 degrees Celsius, and silicon elastoms elastomer silicon elastomer is in the type of class H, and it has a temperature range of 180 degree Celsius. Now last, class C. Class C material used above the 180 degree Celsius. Class C type insulating material is used above the 180 degree temperature, and ceramics and quartz will be used for the class C type material, class C type insulating material. So the above classification is based on the Indian Standard Publication number 1272. 1272. So the above classification is based on the Indian Standards IS publication number 1272. I hope you understood this both the important question in this video lecture. Thank you.